everyone. Welcome to Introduction to In-Depth Solutions for Maxwell Equations. This will be the last part of our electrodynamics and its applications series. And my name is Professor Seung-Bum Hong, and to my right side we have my teaching assistant Melody Glasser. So let me introduce ourselves. I myself is a professor at KAIST and alumni of KAIST, as well as visiting researcher at Argonne National Lab. And Melody Glasser is a student at KAIST. She will receive her master's thesis this year, and she's also a Colorado School of Mines alumni. So KAIST is a university in Korea, and the mascot is Nopjugi, and you can see the symbol of the university. And the location is in South Korea, and you can see this red spot, which is Daejeon. This is a mecca of science and engineering of South Korea. And the next we can see the table, which lays out the overall structure of our lecture series. So you can see if you are here, you already checked number 1 and number 2 and number 3. Congratulations. So the last part of our journey is named Electrodynamics In-Depth Solutions for Maxwell Equations. So you will spend 5 more weeks with us to finish or complete the lecture series. So Melody,
yes.
Among those 4, which one is your favorite?
I like the electric and magnetic fields one because it really started coming together and we can see the larger practical applications like generators. But number 4 is also great, so I'm excited to go through that with you guys.
Very good. What is your choice? I'm very curious. So with that question left behind, let's see what we will cover. So we will firstly recap what we have covered before, including the scope of the first 2 lecture series. So Melody, can you tell our students what we did in the past 2 lectures?
Yeah, so what we focused on a lot was like the visualization. So we talked about like how can we use scalars or vectors or mapping or something to visualize our field. And then we also did derivation. So we told you a lot of mathematical and ways to come up with solutions for many different scenarios. And then we also have taken kind of a look at the full picture. We talked about the microscale, forces between atoms, and then we talked about the macro scale, which is forces in capacitors. So that's just in the first 2 lecture series, and then we also did more in the 3rd one.
Exactly. We covered vector fields, scalar fields, how to visualize them. We also covered micron scale to macro scale, so we covered multi-scale physics in the past lectures. Now, this 3rd lecture series, you have probably understood how magnetic fields are created by rotating current around a loop. You also were able to apply that knowledge to generators or motors that you can see on the right side of the picture. Now, we got still more to learn. So in the final part of our lecture series, we will get seriously into the Maxwell equations in free space and also with charge and currents as the sources. And we will also cover the wave equation, which will describe the fields as a function of space and time. And we will have a lot more equations like the one that is written here to understand the underlying physics. Okay, so in this part of our lecture series, we're going to cover 5 bullet points. Number 1, the laws of induction. Number 2, Maxwell's equations will be revisited with more rigorous approach. And we will tell you about Maxwell's equations in free space. That will include some of the concepts from relativity. We will also cover Maxwell's equations with currents and charge as the sources. And then in the last part of our lecture, we will cover some of the features of AC circuits, which is nicely combined with electrodynamics. With that, I'd like you to stay tuned with our lecture series and embark on the journey. Okay? See you.